This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Okay, hello, my name is Misha, and I'm going to tell you about what we call pain-driven development. But first, short disclaimer. This talk is more of a case study or even a logbook about how few trivial fixes drastically improved the perceived performance. All what I'm going to say might be completely wrong, but that was my experience. Second thing, it's targeted mostly at middle-level audience. Although I'm trying to focus more on high-level decisions, still, I assume you understand basics of how React works, specifically React. Yeah, and the last one, throughout the slides, there will be just one meme, one anime reference, and only one ChatGPT mention. So let's begin. Around January, I was ready to pick a new feature to implement, and I got one from the area I never touched before. And this area was timeline view. To give you some context, what we are even building, we are all-in-one no-code collaboration tool. Or speaking more broadly, it's like a relational database with pretty UIs. And one of such UIs was timeline view. Basically, it's like a calendar-like component with infinite horizontal scroll. Yeah, to users, it might look pretty, but to me, as an engineer, it looked more like this. To give you, again, some of the context, our rendering library was built around an open source solution. This fork was like 5 years old already. It lagged behind the original by a few versions. It was written in pure vanilla JavaScript and used old React syntax. And yeah, cherry on top, original is not maintained anymore. And the performance was kind of bad. You can see those delays. Yeah, it kind of worked, and we always had more important stuff to do. So yeah, everyone pretended that it's okay. But the next 2 weeks I spent implementing this new feature, and it means that I had to spend 2 weeks straight using those timelines and scrolling them back and forth. And it started triggering me a lot, and my pain level started to increase slowly. So we decided to spend one last day to at least try to understand what is going on, and maybe so I can tell what's the effort of fixing it. And where do you usually start? Yeah, you start with performance profiles. Do every one of you know what it is? You know? Cool. So I tried to narrow down the whole scenario, left just a few cards, hit the record button, and scrolled just a bit. And what I saw was this. Yeah, we can definitely see there's some CPU work is going on, like those yellow spikes, but I hoped that there will be something like this. Before we dive in, let's take a step back and just a few tips of how to take more reliable profiles. First one, I suggest you to use incognito mode because, yeah, everything gets tracked by it, even any web extensions you have. I have not a lot of them, but in case you have some sort of MetaMask or Grammarly, it can really mess up your snapshots. Also, I suggest using CPU throttling. It can help to notice smaller details. And the main thing, please use production build. There is a big chance that your problem doesn't even exist in production. But there is one more caveat. Let's take a look at those two functions. Like slow function calls small one in a loop 10,000 of time. And let's try to profile it. And this is how it looks. As you can see, we definitely see slow function, but there are no signs of small one. Do they even get called, or what is happening here? To answer this question, we have to remember how profilers actually work And from what I know, they use a technique called sampling. So when you're, during the period of time your code gets executed, it periodically takes those snapshots of your call stack and builds up this chart. And if you're lucky enough, as I was, there is a chance none of your function will get caught by it. So what does it mean to us? It means that profiler is good for detecting top slow function, but is kind of useless if we have issues with small ones. Let's get back to our issue and zoom in a bit. Here we can see our scroll event and the CPU work it triggered. Also, what else we can see here? We can see that almost the whole function is React work. It re-renders UI. I don't know why yet, but yeah, I don't see any other signs of other functions that gets called. And as we already know, there is not much sense into looking at the bottom level. So let's switch to a better tool for analyzing such sorts of issues, React DevTools. It has a feature of highlighting components that update right now. So let's enable it and try to scroll again. And this is how it looks. And yeah, bunch of stuff happening on the screen, but the one thing that catches my eye are those headers. Because the component looks pretty that simple, why it even needs to be re-rendered. Let's select it, maybe some styles get updated. And once we scroll again, the selection gets reset and jumps to the parent. It can mean only one thing, that this DOM element gets removed and re-added back. And basically, any DOM manipulation on scroll are quite heavy. Okay, we know our problem. We need to get rid of it, and we need to just update those headers. No need to completely remount them. So let's dive into the code of our library. This is the render method of timeline header, and maybe some of you already can spot the issue. Okay, so basically the issue is in naming. They named this property like a function, but instead it's used as a React component. And it means that once the reference to the function changes, React will think that it's a completely new component and he needs to do all the thing all over again and delete it and add a new one. So the fix now is pretty obvious. We just need to make sure that the reference to the function stays stable. Let's go to our application code and the place where we define it. Yeah, it looks like this. For those of you who doesn't know, when one of those dependencies gets updated, the reference to the function also gets changed. And it means that the remount will happen. Where do we start from? First, let's start with some cosmetic changes. Let's rename it so ESLint and our teammates know it's a component. Also, let's remove this thing. In 99% of cases, it's just a code smell and it hides potential issues. Yeah, after it, let's analyze one by one our dependencies. And yeah, those three look really suspicious. Antics and startics are basically our boundaries of visible canvas. So yeah, they indeed update on every scroll event. We can ignore the rest for now. They were memoized, so not interesting. Sorry. How can we fix this? First, the most simple solution is to just move it inside the component and to maybe read those values from our state manager or from React context. Yeah, useTix is for establishing this real-time subscription to our store. Okay, the initial issue is already fixed. There won't be any remounts already, but it's still not great because of this subscription. Still, every header will get re-rendered on scroll event. Still not great, faster, but not ideal. What can we do more? If you take a closer look, startix and endtix are used only inside our zoom function, and zoom is basically on-click handler. So we need those values only when user actually interacts with this header. There is no need to establish this subscription. We just need to get it one time as user interacts. So yeah, obvious solution is to read the state right inside the callback. I don't get much into the details of what is tick store. It depends on your state management solution. But yeah, let's assume we have some API to read state at any time, at any point. And this small change already drastically improved the experience. Okay, yeah, awesome solution. This one went to this, and you can see the difference. Already scrolling experience got much better. I was really hyped about this effect, so I polished all the solution till 3 a.m. And went to sleep. And yeah, this is the story with good ending. The next morning, I was enjoying good feedbacks from my teammates. And I mean, we are a 20 people team. It's almost whole company liked it. Great. But that's not the end. There is actually part 2. Around March, we started working on the new feature in this area related to timelines and etc. And yeah, the difference might be like subtle, but believe me, it required a lot of small changes inside the library to complete this view. I already envisioned the amount of pain I was going to feel on myself. So the next thing I did was this. This change might seem silly. It's just conversion of JavaScript to TS, maybe updating some imports to use our own helper packages. But the biggest benefit of it was that I got familiar with the library, I learned it, and I was not afraid anymore to contribute into it. Basically, I started owning this piece of code, and it stopped being a black box to me. So it unlocked new possibilities of future optimization. Around that time, I was planning my vacation, and I opened the only one timeline I actually use in my day-to-day life. It's all vacations timeline. And yeah, the experience here was still garbage. And I use MacBook Pro, Max, I don't remember. So yeah, it's definitely not acceptable. If you remember, I spent implementing first feature for timelines. I spent around 2 weeks. Implementing Gantt view, I spent 3 months or so. So yeah, I had my rage moment here. And I decided that it's time to actually do something with it. Let's start one by one. Scroll delays. If you implemented or used virtualized UIs like tables, it's pretty common pattern to have separate scroll containers for headers and the body. And even such giants like AG Grid has this issue. It's just impossible to get rid of this delay if you scroll. I think it's related to MacBook hardware acceleration, but I'm not sure. And that's what I told to all my colleagues, that we just can't do anything about it. But then one day, one of my colleagues asked the main question, why? Why do we even need those separate containers? And indeed, I tried to push headers under the shared container like this, one line change, and it fixed the issue completely. This one line fix was the most impactful thing I ever done in my career. Okay. Let's go to the next one, panels resize. So when there is a feature of resizing, you could drag this left panel and resize it. And what we were doing, once we start resizing, we were rescaling all the timeline body. We were recalculating all the collisions, all the item positions, and etc. And yeah, it's heavy. So the best solution to it is just stop doing it. But once you drop this rescaling feature, one more problem arises. Since it's infinitely scrollable canvas, it has some strict limitation to its size. It needs some fixed constraints. And once you resize the panel, you have to update the width of canvas body. It still might be faster than what was before, but can we maybe avoid all work? And yes, we can. We just need to make our panels float. And that's basically how it works in any design software you use, like Figma. Also, it's how it worked in our competitor tools. The next one, sticky titles. This one was fun because it worked okay before all the fixes, but it got slower. And yeah, initially I implemented it using CSS variables and intersection observer. It worked fast until we made our panels float. And yeah, when I took another snapshot, I saw those huge purple spikes. Purple means that you have a problem with rendering and it takes too long. Turns out that sometimes CSS is slower than JavaScript, and you should avoid updating frequently variables on containers that have many children. So I switched to JavaScript solution and just derived those flags and values from our state. And it was much, much faster. Yeah, you can scan this QR. This is a good article about CSS variables performance and its impact. I think it's from 2K17, but still quite good read. Okay, time for results. Yeah, scroll delays are gone completely. Yeah, you can see how it was scaling and super slow. Became much better. Still not ideal, but already okay. And right panel got faster as well. Huh? Yeah. Same my MacBook, actually, it's same screen and two browsers, one by one. Okay. So this is how the title of this talk was born. As you can see, my colleagues went so surprised by this improvement this time, only 8 instead of 13, but okay. And the morale of this story, first point, don't treat your dependencies as black boxes. Once you add the dependency into your project, it becomes your responsibility. Also, just by reading and patching it, you can learn a lot and improve yourself as a software engineer. Also, in my opinion, dogfooding and Boy Scouting are like the most important pieces of dev culture. Without it, I can't imagine how you can achieve like really polished product that is loved by others. Yeah, if you have super powerful MacBook, please use CPU throttling. Test your hypothesis. And the last one, I mentioned it slightly, actually compete with your competitors. We are lucky and we have really high quality ones like Notion or Linear. And I always compare our solution to theirs. And if they can make something fast, why can't we do the same? And yeah, soon after this, we had a demo for one of our largest potential customers, and their feedback included this piece. You never know what catches users' attention, and it feels really nice. And that's basically it. This was my first big talk ever. Hope it wasn't too bad. If you want, you can give me anonymous feedback, or yeah, this is my Twitter. I'm trying to post a bit more right now. Other my contacts you can find on WarsawJS website. That's it.
Hey, way to go! That was your first talk ever.
Yeah.
Amazing job. That was a way to enter the scene.
I mean, I did once a presentation at Hackathon, but
We have our first question.
I kept noticing that you use callback on interval renderer component, because that part looked like a regular functional component, but it was wrapped in a
sorry,
use callback.
I didn't hear the beginning of the question.
Okay. I couldn't help but notice that interval renderer component was actually a hook, use callback.
Okay.
So it renders JSX, but it's a use callback, and I'm curious how did it end up?
Yeah, as I said, the whole library was written like 5 or 6 years ago, and then barely anyone touched it. So yeah, that's how it ended up there. And why it was use callback initially, because the prop was named also interval renderer, and it looked like a simple plain function. We assumed that this library waits for a regular function, and if they use it as a function instead of using it as a component, then there won't be any remounting issues. I hope you answered your question, but yeah, what I showed here was just a draft to verify my hypothesis. Later, I polished the code more and moved it to a good-looking component.
Yeah, that's what I wanted to ask. I was hoping for a happy ending for that component.
Okay. Yeah, it got some love.
Sorry, you mentioned dog fooding. I get dog fooding. What is Boy Scouting?
Boy Scouting is basically your initiative. Like, no one told me to improve the performance of timelines. It was kind of okay. But yeah, I was using it and I felt the power that I can fix it. So yeah, I just went and fixed it.
Right. Okay. No. Well done, you. Bro.
Any more questions before you clap? Wait. No? No hands? All right. Now you can clap.